Good day, folks. Welcome to Brett Mind Academy, where we bring brilliance to every lesson. Now, let's continue where we left off in the previous video. It was a long video, I'm aware of that, and sorry for that. But yeah, you know when you have to explain a concept, it's like that when you introduce a topic. Okay, today's video, I'll try to make it short and simple, okay, but still making you understand. Now, remember we left off where we talked about hydrocarbons, alkane, alkene, and alkyne, right? Now we're going to move on to the fourth compound that we're going to be dealing with, which we now refer to as a haloalkane. This is another homologous series. Okay, this is another homologous series that we are dealing with. Homologous series, okay, of alkane. But now let's be in a position of knowing what exactly is an haloalkane. Can you see from the word halo? Sorry, halo comes from a halogen. Okay, it is twisted. Let me do this. Okay, now halo comes from a halogen. Okay, let me do this. This word is composed of now halo from halogen, and this is what an alkane. What is this? Remember, we have haloalkane. Okay, so now we only know alkane. We only know alkane. Now, what is a haloalkane? A haloalkane, it is now a type of organic uh, molecule in which one hydrogen is substituted by what? By a halogen. Or instead of having maybe something like H everywhere, now we are doing what? We're going to be substituting what? We're going to be substituting a one hydrogen with what? With a halogen. Okay. We now be in a position of doing what? Of understanding. So now, okay, let's talk about the structure of a functional group. What makes this special? Okay, what makes this special is that, okay, we have a carbon, but within that carbon and those bonds of carbon, one of the bonds there should consist of a what? Of a substituent, which is now what referred to as a halogen. Whereas now this X can either be what? Fluorine, bromine, or iodine. Okay? Where X can be what? Can be fluorine, chlorine, bromine, or iodine. Okay? But now you're gonna see the interesting part when we name. When we start naming this, when we start naming, can you see I'm saying it is fluorine, chlorine, and bromine and iodine. But when we start naming, we'll now call them fluoro, chloro, bromo, iodo, like that. When we start naming, okay? All right. Now, let me just even name it. Let me just say it here. When we deal with F like that, it's gonna be what? Cl, bromine, iodine. When I start naming, I won't say something fluoro. So I won't say 2 fluorine hexane, maybe. I'll rather say what? Fluoro. I'll use fluoro, and here I'll use chloro like this. Fluoro. Here, can you guess bromine? Bromo. Here, can you guess iodine? Iodo. Okay, these are the words that will be using for now our substituent thereof. Okay, now it can only be limited to now to 3. Okay, we can only add 3. If now it is no longer one fluoro, it can either, if there are 2 of them, it is difluoro or dichloro or dibrom or diiodo. Okay, if there are 3 of them, we call them trifluoro, trichloro, tribromo, triiodo. Okay, Okay. Okay. But now, according to the exam guide, we only limit it to three what to three substituents there, or three what halogens thereof. Oh, okay. So what? So what? Okay, we know a functional group. It is this, where now X represents a what? Represents a halogen. Okay. We do not want to say Br, because what if that halogen, it is not Br, it is rather Cl indeed. So we go to our what? Our general formula. This one will be the same as, remember, this one will be the same as a what? The same as alkane, because we take this haloalkane from alkane. So remember, for alkane, it is CnH2n plus 2. But instead of plus 2 hydrogens, they did what? They removed a CnH2n plus 1. Why? They removed one hydrogen with a what? With a halogen. Sorry, they removed one hydrogen with a halogen. So we're gonna say, okay, from the hydrogen we're gonna remove one, and but replace it with what? With a halogen, like that. So the general formula will be CnH2n plus 1x. Okay, yes, this is the general formula thereof. Okay. Then now let's move to what we now okay, let's have examples, or the prefix. Okay, the prefix here is the same as alkane. Since when we inherited this from alkane, not ake, it will just be alkane. Okay, now let's have examples of that. Let's have examples naming haloalkane. Haloalkane. Sometimes haloalkane are referred to halohalides. Okay, sometimes they are referred to as halohalides. So when you see halohalides in one of the question papers, do not get amazed. It is haloalkane. So naming a haloalkane, what do we prioritize? This one is very, very tricky. Very tricky above from all of them, because wow, I remember very well when I was doing my grade 12, I was very, very stuck in an exam room on whether to prioritize. On here, we did not prioritize a branch or a halogen. We prioritize the one that gives us the smallest number. Prioritize substituents. Substituents that, okay, let me do this. Uh, Prioritize substituents that give you the smallest number. What do I mean by that? A substituent can either be a branch or a halogen. This is what we refer to as a substituent. It can either be a branch or a halogen. Now, what do I mean by that? Okay, let me have this. The question is, what if they have the exact number? Okay, I'll come to that one. Mhm. Why are we saying this is a haloalkane? Because now, can you see alkane? It has single bonds everywhere, so it qualifies as a what? As a alkane. Between carbon-carbon bonds, it has single bond. Can you see that? Single bond. So it qualifies as a alkane. But now, what kind of alkane? Haloalkane. So okay, why? Because we have a bromine. So it is under a homologous series called haloalkane. Exactly. So now, when I name Check this. When I name, I do not prioritize a halogen, or I do not prioritize a what? A branch. I want you to see this. This is 1, 2, 3, 4. When I start counting from that side, if I start counting from my right, it is 1, 2, 3, 4. So now I want you to see something. You get a what? You get on number one when you use red. On number one, you have a what? A bromo. Bromo. Remember, you not say bromine, you say bromo. And on carbon number three, you have a methyl. So can you see when we add this, it gives us how much? A total of 4. Okay. Let's see now on when we use a what's this? When we use blue. When we use blue, counting from the blue, it is 1, 2. On number 2, I have a what? I have a methyl. On number 1, 2, 3, 4. On number 4, I have a what? A bromo. So can you see when I add this, in total, they give me what? 6. So I want the one that gives me the least, which is one, which is this one. So it means I'll start counting from the red. Can you see now the importance of knowing where to start? Now, another thing, according to Ayupak name, when you name, you should, all your things should go in an alphabetical order. What do I mean? Now, these are your substituents, right? But they will follow each other in an alphabetical order, not the numerical order. Alphabetical order. What do I mean by that? Let's try to name this. Let's try to name this. When I try to name this, remember the longest chain, it is what? 1, 2, 3, 4. Remember, when you name an alkane, the longest chain, it is bute. You just say butane. Again, you do not say bute 1 something or bute 2 something. Why? Because this is under alkane, and alkane, you just say butane, hexane, whatever. Okay. Now, what's important is this that will follow here. What follows? You're going to say, on my longest chain, I met what? On carbon number 1, I met bromo. On carbon number 3, I met methyl group or a branch. Now, between B and M, which one comes first? Do you agree with me that the bromo comes before methyl? Yes, so it means I'm going to have 1 bromo, 3 methyl butane. Okay, this is the correct naming. What if you said 3 methyl, 1 bromo, butane? This is wrong. Why? Because M does not come before B. Rather, B comes before M. This is one of the multiple choice questions they like. Okay. We are good with naming this. Okay, let's have one example again. Again, I should be in a position of knowing how to convert this writing here into what? This IUPAC name into what? Into a structure. Can I do that? Butane. Butane tells me it has 4. 1, 2, 3, 4. But it is A and it has single bonds everywhere between carbon atoms. Okay. Then I'm told on carbon number 1. Well, I'll start counting from here. 1, 2, 3, 4. You can start counting from there. It's fine. On carbon number 1, what do I have? I have a bromo. Oh, okay. I have a bromo. On carbon number 3, I have a what? Sorry, a methyl. Oh, I can put methyl here or there. Okay. Just I prefer putting it where I have enough space, where I'll put it here. H, H, H. Oh, okay. Oh, okay. Need. Okay. Okay. Oh. Is it the same as that one? Is it the same as that one? Indeed. It is the same. Okay. The structure is the same. If you started counting from here, let's say you had 1, 2, 3, 4, then it means your BR was so gonna be here. Then your branch was gonna be here. Okay. Yes. Let's have one example on naming now a haloalkanes. Let's say I have okay. What's this CC? Let's say I have another C here and here. Then I continue like that. Okay. Okay. Let me have an H here. Mhm. Let me just put CL here. Yeah, you can get a very, very, very complicated thing like this one. It is very possible. Now let's start counting. If I start counting from here, it's going to be 1, 2, 3, 4, 5. This is 6. Okay. If I continue not going there, it's 6, 7, 8. Okay. So instead, I prefer this one. Okay. Mhm. If I start counting from here, it's going to be what? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Oh, okay. Now, let's check the substituents in terms of this one to know which one, whether we start counting from here, from the blue or from the red. Let's see the red. This is a branch, right? We see this is a branch. This is a halogen. This is a halogen. Okay. Now let's see when we count. We have what? 1, 2, 3. On number 3, let's use red to see, to show we are using the red numbering. On carbon number 3, we have chloro. Okay. Then on carbon number 6, we have a bromo. Then on carbon number 5, let me say 5, we have a methyl. Then on carbon number 6, we have a bromo. Okay. Now, the total in here, it is what? 8 plus this, it is 14. So let me use a color. 14. Now let's do the numbering for when I use the blue one. So it's gonna be 1, 2, 3. On carbon number 3, I have a bromo. Then on carbon number 5, I have a what? Carbon number 5, I have a what? Carbon number 5, so I'm losing focus. On carbon number 5, I have a methyl. Carbon number 6, I have a what? I have a what? What? A chloro. Sorry, I don't know what's happening. Then when I add here also, I get 14. I like this. The question is, which one do I prioritize now? Because all the numbers that I get here are the same. So which one do I prioritize? Now, that's where you say now, okay, I look at my alphabetical order thereof. Okay? I look at my alphabetical order. I know bromo comes before what? Bromo comes before chloro. Okay? Then similarly here, bromo comes before chloro. So what will happen? I will want bromo, since well it is the one that starts, to have the first, to have the what? To have the least number. Okay, since well bromo is the one that is starting, I want it to have the least number, which is bromo. Okay, I'm taking bromo because between B, C, and M, it is the first letter that we'll start with. So between B, C, and M, which one do we start with? We start with B. So between these two, this one and this one, which one has the least number? It is this one, all right? So it means we're gonna take this one. Okay. What if the number were the same? We're going to move on to saying, okay, the next letter is chloro. Between this chloro and this chloro, which one has the least number? It is this one. But in this case, we started with bromo and we can see which one is the least number, okay? So it means we'll start counting from what? From the blue. Can you see how tricky it is? I know, trust me, I know it is. Haloalkanes makes your life a little bit difficult sometimes, unnecessarily sometimes. So now we're going to use this again. So we're going to say, okay, the name of this one, since well we know the longest chain, it is oct, it's going to be octane. Because for alkane, we just say the prefix, the number of carbons, then the functional group, which is ane. or the prefix and suffix. Now, what are we gonna say now? We're gonna say, okay, if we have that, let's now be in a position of saying, okay, let's output this in an alphabetical order. We're gonna start with what? Bromo. It's gonna be 3 bromo, then follows 6 chloro, then follows 5 methyl. So it's gonna be what? It's gonna be 3 bromo, 6 chloro, 5 methyl octane. Ooh, I've never seen a name like this, but it is possible. Okay, it is possible to have a name such as this one. For 3 marks, the maximum that you can get it is 3 marks. Okay, yes. Also, given this structure, you should be in a position of knowing how to draw this. Let's try to do that. I have methyl. Okay, I have octane. Octane tells me it is 8. 1, 2, 3, 4, 5, 6, 7, 8. Then I have what? It is octane. It means there are single bonds everywhere between carbon. Okay, it is not in where we have double bond. Then I am told what? On carbon number 3, I have bromo. Then let me start counting. 1, 2, 3, 4, 5, 6, 7, 8. I'm told that on carbon number 3, I have a bromo. Okay, and carbon number 6, I have a chloro. On carbon number 5, I have a methyl. Then the rest will be just hydrogens. Okay, I won't fill up them. I won't fill them up. I will be tired. But okay, when you draw, can you see now the structure? Is it the same as that one? Let me try to do this. Is the structure the same here? No. Why? Because the longest chain here, it is straight, but here it is like that. The question is it wrong? The answer is no. Why? As long as I can take this structure and get the name, this one, and take this structure and get this name, then it means everything is perfect. Okay. Remember, I said the structure does not matter. What matters is that the structure that you have drawn it is correct and can go back to the name that you were given. Okay. These are the very basic things that I need you to understand. Now let's move on to the types classification of haloalkane. Okay. Classification of haloalkane. I forgot something. On the previous video, I forgot something. Okay, but it's nothing very, very, very deep. We'll just add it further. Okay, we'll say now. Where did I start? We'll say here this is a saturated compound. What do we mean it is saturated? A saturated compound, it is a compound that has single bond between C atoms. Between C atoms. Okay? Yes. This is what we refer to as a saturated carbon compound. Okay? Or saturated hydrocarbon. Now, when we say it is unsaturated, this one, it is unsaturated. Remember saturated for single. Okay, I want you to take it like this. Saturated for single, unsaturated for unsingle. So we're going to say the definition for this one. Okay, on that one, you said it is a compound that has. So, but for this one, we'll say the definition, it is what? A compound that has or consists of multiple bonds. Between what? Between carbon atoms. If you do not want to say multiple bonds, you can say that consists of 2 or more bonds. Okay. Similarly, if I come here and say this one will it be saturated or unsaturated? Unsaturated. Rated. We already know why is it unsaturated. Okay, yes. Now let's come here. Classification of haloalkane. We have what we call a primary haloalkane, haloalgesis, haloalkane. We have what we call now, we refer to as secondary haloalkane. We have what we refer to as now 2,4, what we refer to now as tertiary haloalkane. Okay, yes. Now, what is the definition for primary haloalkane? A primary haloalkane, I want you to see this. If I have this, Br, H, 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 H. You need to draw the structure to see if it is primary or secondary. Okay. Now, I need this. Let's define this first. What is the definition of a primary haloalkane? A primary haloalkane, it is a what? We say, let me confirm that. Okay, it is a primary haloalkane. You're gonna say a carbon bonded to the halogen is bonded to one other carbon atom. What do we mean by this definition? You are saying the carbon bonded to the halogen. Which one is that? This one. Okay. Should be bonded to one other carbon, not many carbon. What do you mean? This carbon, it is bonded. Okay, let's look at this carbon. And I call it the king. Okay. The carbon that you are talking about, it is this one. I call it the king. Why? Because it is the one that is bonded to the halogen. Let's see. It is bonded to how many carbons? Let's see how it is bonded to what first. It is bonded to this, as well as that, as well as that. Okay. Now, how many carbons is it bonded to? Can you see it is bonded to only one carbon? Why? Because why can you not say this one? Because this one, it is not directly bonded to that one. It is rather bonded to this. Okay. This one is bonded to this, not that. Can you see? So hence we are saying this one we classify it as a what? As a primary haloalkane, because why? The carbon, the definition says for itself, the carbon bonded to the what? To the halogen, which I refer to it as a what? As a king, is what? Is bonded to one other carbon atoms. We are focusing on carbons. Okay. So, okay, that is good. So what will be the what will be the secondary alcohol haloalkane then? The secondary alcohol will be a carbon bonded to the what? Still the same halogen, okay? Halogen. Now, what will differ is that this one is bonded to how many? Secondary to two other carbon atoms. Can you see the difference is that this one is bonded to one other, okay, my English gone, to one other carbon or to just one carbon. This one is bonded to two other carbons. What do you mean by that? What if we have this? Uh, what if I have that? Okay. What if I have that? Now, the definition says the carbon bonded to the halogen. Which one is that? The king. Where is the king? Here is the king. Is bonded to two other carbons. Let's see. King is bonded to this, this, as well as this. How many carbons is king bonded to? King is bonded to one carbon and two carbons. So this qualifies as a what? As a secondary haloalkane. Okay. So can you see now we are cruising nicely about this one? This one will be what? A carbon bonded to the what? To the halogen is bonded. Can you guess this one? Yes, is bonded to three other carbon atoms. How? How? Like this. See, 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 see. I don't care how long it is. Okay, let me not just use BR because I've been using BR everywhere. It's just that it isn't just the easiest and the one that they like the most. Okay. Now let's talk. The definition says an atom, so not an atom, a carbon bonded to the halogen. Which one is that? Where is the halogen? Here is the halogen. Where is that carbon bonded to it? Here it is. We call it the what? The key. Is bonded to three other carbons. Is it true? Let's see. This carbonate is bonded to this one carbon, to this one carbon, to this one carbon, also bonded to fluorine. Now, how many carbons is it bonded to? Three. Oh, this is what they now mean when they refer to what as they refer to as primary haloalkane, secondary haloalkane, as well as tertiary haloalkane. You need to be in a position of knowing how to define. You need to define this. You need to know how to define that. Very, very important. You need to know how to define haloalkane, sorry, tertiary alkane, hypo. Sorry, where is my English data going? Primary haloalkane, secondary haloalkane, and tertiary haloalkane. Now let's move to the last one for this video, which we now refer to as alcohol. The reason I paired them because they are similar, okay? Let's look at number 5. What? Alcohol. Alcohol, it is just a what? A not, yes, homologous. This is just a homologous series. Okay? Homologous series. Now, alcohol, exactly the alcohol that you know. Okay? Now, if you're drinking alcohol, which I wouldn't advise you, if you are, and I'm offending you, I'm sorry, I'm not talking to you, I'm talking to you, the one who's not drinking. Continue not drinking. This is the alcohol that we refer to that Jesus Christ created. Now, this alcohol is just a homologous series. What's its functional group? Functional group. The functional group of this one, it is alcohol. Well, when we define alcohol, we say now it is a compound in which now it is taken from haloalkane also, okay? Sorry, from an alkane also, okay? But instead of substituting an H with a halogen, they substitute an H with a what? With an hydroxyl group. Right? Now I start talking the functional group, hydroxyl group. So they substituted an H with a hydroxyl group. What do I mean? If I have C like this, I'm expecting this to be hydrogens, hydrogen again. But now instead, it is now substituted by the hydroxyl group. What is that? This is what we refer to as a hydroxyl group. If they ask you what is the functional, name the functional group of alcohol, it is what? Hydroxyl. Hydroxyl group. So hydroxyl group, it is the OH group. Okay, hydroxyl group, it is the OH. Can you see now they substituted now what? They substituted now hydrogen with a what? with a OH. Now, this is when they ask you to draw the structure of a functional group. What is the structure of the functional group of alcohol? It is this one. But what is the name? The name of the functional group. The name of the functional group, it is hydroxyl group. Okay? The name of the functional group, it is the hydroxyl group. Okay? Now, what do we know? The general formula of this one. It will be the same as the haloalkane. Remember, in haloalkane, we say it is CnH2n plus 1, then they added a halogen. But in this case, instead of halogen, they added what? OH. So it's going to be, oh, okay, CnH2n plus 1 OH. Oh, it tells me, oh, they removed one a hydrogen, but replaced it with what? With this. You can also write it like this. CnH2n, then take this hydrogen and add it here plus 2O. Okay, but it's a little bit bad. Just write it as CnH2n plus 1, then tell us or they added and what? An OH thereof. All right. All right. Now, the suffix for this one, remember we deal with suffix. Suffix for this one, we know we took it from a haloalkane, but it won't end with a. In case it's gonna be end with this. So we are starting to know how we can put a suffix for this one. It is an alcohol, so it will end with all. Okay, so the suffix will be all, ol, alcohol, butanol, methanol. Okay. So we'll have here naming. On alcohols, then we can say, okay, on this one we prioritize, prioritize, prioritize. I don't know how it's written. Hydroxyl group. You prioritize the functional group, which is what? Which is OH. Okay, you prioritize the OH. You prioritize the OH. The OH is referred to as the hydroxyl group. Indeed. Indeed. Now let's name. Let's name this. If I were to name this, this is just basic. I want you to show you this. This is what? The longest chain, it is one, it is myth. Myth. Remember when I name, I should tell the examiner or the functional group that I see it is on carbon number one. This one is found on carbon number 1 again, but it cannot be found on other carbon again. So I'll just say methanol. There's no need to say it is methane, one all. No need for that. I'll say it is just what? Methanol. Okay. Another example, I'll say, okay, if I have this OH, I can put OH here. Anyway, okay. The name of this one will be what? One. I'll start counting from here. It is 1, 2. Okay. So it is gonna be what? Ethan. Ethan what? I won't say Ethan 1 all. Why? Because if I take this part to the other side, can you see it's gonna be written? It's gonna still be the same. Can check if I take this one and take the OH to this side. Okay, this is bonded very bad. Can you see it's still on carbon number 1? Number 1, number 2. The name still ethan 1 all. No, instead we just say it is ethanol. Okay, ethanol. Okay, we start naming, we start numbering from, okay, let me note this. Start numbering from prop. Okay, we start numbering from prop. Let me see also here. Also for the haloalkanes, if I start naming I start numbering from prop. Actually, for all of these, I start numbering from prop. Okay, I start numbering from prop for all of them. Okay, please take note of that on your notes. Okay, yes, and I want to believe you are watching this video already. Already, you have already watched the previous video. Okay, so this one is just gonna be ethanol. Okay, I know I said the prefix it is eth. Okay, but you can't say ethyl or methyl. Okay, starting from alcohol going down, you just put methane. Okay, methane. Okay, these were the basic one. I did not need them. I was just okay. Let me just. It's fine. Say here it is methanol. Now let's look at the names that are a little bit interesting now, such as what, such as let's say we have a structure like this. Okay, we have a structure like this. I want us to give the IUPAC name of this structure. Uh, when you start naming, you prioritize the hydroxyl group or the OH. Where is OH the smallest? When I start here, can you see that? 3, this is going to be 4 if I go there. If I continue, it's going to be 4 like that, 5. So it means the longest chain it is this one. Okay, so it means I'll just erase this one. Okay, you are not the longest chain. But what will be this? This will be a what? A branch. Can you see that? Yes. So it means when I name, I'll say, okay, my longest chain, it is 1, 2, 3. Can you see now my number of carbons have exceeded 3 or are exactly 3 or more. So I can start numbering. So I'll say, okay, the longest chain it is prop. Yeah, pent. Longest chain it is pent. But I won't just say pent, I'll just say pentan. Okay. Now the functional group of the alcohol, it is what? It is OH. Can I see OH? I see OH somewhere. Okay, I see OH on carbon number 2. On carbon number 2, I have what? An all. Or all, like that. Okay. Or I have a longest chain of pent, but on carbon number 2, I have an all. And I know an all, it is a functional group of what? Of OH. Oh, okay. Then I'm not done. I have what? Also, I have a branch on carbon number 3, and that branch, it is meth. So I'll have 3 methyl. Let me do 3 methyl. 3 methyl pentan 2 all. So it is like this. Yes. Some people say, okay, I don't want to talk about that one. No. It's fine. 3 methyl pentan 2 all. Can I be in a position of throwing this? Yes. Why? Check. I start here. Pentan. Pentan tells me it is 5. 1, 2, 3, 4, 5. And it is all. Okay. Alcohol has single bonds. Okay. Then now I'm told that when I start counting, I'll just counting from here. It's fine. Wherever I want. Okay. I can start from here to there or from there to there. It's fine. Now I'm told on carbon number 2, I have an all. What is an all? What is an all? I know an all, it is a functional group of what? Of OH. Oh, okay. Then on carbon number 3, I have a what? On carbon number 3, I have a what? A methyl. I have a what? A methyl. Oh, okay. Then the rest will be what? Hydrogen, 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 and hydrogen. Oh, is this the same as that one? No. Why? Here we had the carbon on the right hand side, or rather the OH on the right hand side. But on this one, why do I have the OH on the left hand side? Yeah, it does not matter. As long as it is on carbon number 2. What's important is that it is on carbon number 2. Similarly, here it is on carbon number 2. The meth is on carbon number 3. The meth is on carbon number 3. It means now when I name this, what I've drawn, it means it will give me the same same name thereof. So okay, it is correct. Now let's have one other name. What if now I mix? What if now we already know the carbon? We already know the. Okay, it's fine. Let's just name these ones. It's fine. We'll see the mixture as we move on. Let's have the last example. Let's say, what if I have C, 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 C? I don't know what to do. O, H. Mm-hmm. Mm-hmm. Yes. Okay. All right. Should I be silly? I'm thinking of becoming a little bit silly and put a CL here. Oh, whenever you are making this big, no, it's not big. Trust me, it's not. Why? Because now it's still the same thing. You just need to know what you have. What I have, okay, is longest chain. What do I start counting from? I start counting from what? Alcohol. Remember, I prioritize what? Alcohol, or rather the OH group. So I'll say, okay, this is 1, 2, 3. When I go there, it is 4. If I didn't go up, down, I went up, it was going to be 4. If I went straight, it was going to be 4. So either way, but I'll prefer the straight one. So I'll say, okay, like that. Now, I say, okay, my longest chain, I know it is, my longest chain, it is bute. But since well, it is alcohol, I'll say it is butane. Butane, what did I meet? On carbon number 2, I met the what? The hydroxyl group, which is the OH. Okay, but that's not what I only met. I also met what? On carbon number 3, as well as carbon number 3, I met a what? A methyls. Okay, I met a methyl here. I also met a methyl there. So I call them what? I say, okay, I met two methyls. Okay, so I'll say, okay, I have 3, 3 because they are on the same position. What? Di. There are two of them. What? Methyl. What? Butane. This is now the IUPAC name for this compound thereof. Oh, okay. I forgot something. Oh, sorry. I forgot something. I forgot something. Okay. Okay. We already have, let's collect our data. We have butane, 2 all. Then we have 3.3 dimethyl. Then we have what? What's this? 4 fluoro. Okay. Now, when we name, remember this one will be the ending. Okay. When we name, remember we want them to be in an alphabetical order. So don't the die we do not count it as a alphabet. Okay. Yes, it is an alphabet, but we do not consider it because it just tells you there are two of them. We'll start here. This is M. You'll compare between M and C. Okay, so you'll say, okay, C comes before M. So you'll say, okay, this one, it is what? I'll start with this one. You'll say it is 4 fluoro, 3.3 dimethyl, methyl what? Butane, 2 all. Oh, but now can you see D comes before C? Yes, I understand that, but when we name, we do not consider di, tri, or what? Okay, di or tri, not considered during arrangement. Okay, I hope it's clear. The die and try, you do not consider them. You just consider after the die. What is that? Is myth. Okay. So that is it. So that is it for these two compounds thereof. So now let's meet again on the next video. We'll be discussing two other compounds. I'll just break them into two now. Okay. We'll be doing now aldehyde, as well as ketone. Okay. Yes. Aldehyde and ketone. Now, yes. Thank you very much. Join me on the next video. Thank you.